वेलकम स्टूडेंट्स। आज हम लोग फिजिक्स क्लास 12 में फिजिक्स का पहला चैप्टर कूलॉम्ब्स लॉ एंड इलेक्ट्रिक फील्ड, इसमें हम लोग कूलॉम्ब्स लॉ के बारे में पढ़ेंगे। कूलॉम्ब्स लॉ का टॉपिक पढ़ेंगे और ये चैप्टर जो है वो इलेक्ट्रोस्टैटिक्स के अंतर्गत आता है। इलेक्ट्रोस्टैटिक्स से 4 चैप्टर हैं, आपने किताब में देखा होगा, तो उसमें ये पहला चैप्टर है कूलॉम्ब्स लॉ एंड इलेक्ट्रिक फील्ड। इसमें हम लोग वी रीड अबाउट द कॉन्सेप्ट ऑफ कूलॉम्ब्स लॉ से पहले इस चैप्टर में सबसे पहले वी रीड अबाउट द कॉन्सेप्ट ऑफ चार्ज। व्हाट इज द कॉन्सेप्ट ऑफ चार्ज? चार्ज क्या होता है? तो इट इज सीन दैट, ये बताया गया है, इट इज सीन दैट व्हेन वी रब एनी बॉडी टू अनदर बॉडी then it is having a property of attracting the other object because they are charged. Because they are charged, due to the charge they are attracting to the other object. And how they are charged? The reason is that when we rub any body to other body, that there is a transfer of electron from one substance to other substance. We know that every object is made of a small particle that is called atoms. An atom having a nucleus and electron are moving around the nucleus. The substance is made of these atoms. So when we rub any body to other body, the electron get energy. We do work against the friction, and due to this friction the electron get energy and they become free and transfer from one substance, so they become free and transfer from one substance to other substance. So due to the transfer of electron, the object becomes charged. When n number of electron is transferred from one substance to other substance, then the charge present on the substance Q is equal to Ne, where E is the value of one electron, that is 1.6 into 1.6 into 10 to the power minus 19 coulomb. N is the number of transfer of electron, Q is the charge. The unit of charge is coulomb. With this formula we can find out the charge present on any substance when we know how many number of electron are transferred from one substance to other substance. And we can also say that the concept of charge is a property of the substance by which it apply to the electric force to the other substance. This is the definition of charge. And uske baad, now the fundamental charge. What is fundamental charge? The definition of fundamental charge. The fundamental charge, the minimum charge produced on any substance is called fundamental charge. And the value of the fundamental charge is also 1.6 into 10 to the power minus 19 coulomb, because minimum one electron can transfer from one substance to other substance. And those substances in which the electron are weak, it is having positive charge. And those substances in which the electron are enter, it is having negative charge. So we can say that the charges are of two types, positive charge and negative charge. Positive charge and negative charge. And it is seen that same type of charge always repel each other and opposite type of charge always attract each other. It means they are applied force of attraction or repulsion. Before we read the Coulomb's law, we know the value of what is the definition of quantization of charge. Quantization of charge क्या है? The charge produced on any substance is always multiple times of fundamental charge, either plus minus E or plus minus 2E or plus minus 3E. Not between this. This is called quantization of charge. Because the transfer of electron cannot be divided. The transfer of electron is R1, R2, R3. That is why the charge produced on any substance is plus minus E or plus minus 2E plus minus 3E. This is quantization of charge. And also the law of conservation of charge, the concept is given. The charge can neither be produced nor can be destroyed. The total charge of any system remain constant. Suppose we can take two objects, initially their charge is 0, so the total charge of the system is 0. But when we rub it, suppose two electrons are transferred from one substance to other substance, the charge produced on this object is plus 2E and the charge produced on other is minus 2E. So the net charge will also be 0. So the charge neither can be produced nor can be destroyed. The total charge of the system remains constant. And now we read about Coulomb's law. We know that the same type of charge always repel each other and opposite type of charge always attract each other. It means they are applying force of attraction or repulsion. That is given by the what is the value of force of attraction or repulsion? That is given by Coulomb's. That is called Coulomb's law. What is Coulomb's law? Coulomb said that the force of attraction or repulsion acting between 2-point charge is directly proportional to the product of the magnitude of the charge and inversely proportional to the square of the distance between them. These are 2-point charge. Coulomb's law given the force of attraction or repulsion between 2-point charge. The value of, suppose these are two charges Q1 and Q2. They are placed at a distance r from each other. So the Coulomb said that the force of attraction or repulsion acting between these 2-point charge is directly proportional to the product of the magnitude of the charge and inversely proportional to the square of the distance between them. When proportional is removed, we apply constant. The value of the constant is 1 upon 4 pi epsilon naught Q1 Q2 upon r square. Where 1 upon 4 pi epsilon naught is constant, its value is 1 upon 4 pi epsilon naught is constant, its value is 9 into 10 to the power 9. 9 into 10 to the power 9 Newton meter square upon Coulomb square. The unit is taken from this formula, 1 upon 4 pi epsilon Newton meter square upon Coulomb square. And epsilon naught is also constant. Its value is 8.85 into 10 to the power minus 12. Coulomb square upon Newton meter square. Epsilon naught is called permittivity of free space. The flotation power of electric in vacuum, that is called permittivity of free space, that is very low, 8.85 into 10 to the power minus 12. When these charge, this is the formula when the charge are placed in air or vacuum. When these charges are placed in some medium whose dielectric constant is K. Dielectric constant is a property of the substance which decreases the force of electric force between the charges. That is why when the charge are placed in dielectric substance, the value of the force is 1 upon 4 pi epsilon naught K Q1 Q2 upon r square. And but for air or vacuum, the value of K is 1. So F is equal to 1 upon 4 pi epsilon naught. For air or vacuum, the value of K is 1, Q1, Q2 upon r square. This is Coulomb's law. Coulomb's law is as same as the gravitational law. In class 11, we read Newton's gravitational law. Gravitational law is the force of attraction acting between 2-point mass is directly proportional to the product of the magnitude of the mass and inversely proportional to the square of the distance between them. That is same. As in gravitational law, mass are taken. In Coulomb's law, charge are taken. But there are some similarities between them and there are some differences. Coulomb's law, similarities are Coulomb's law and gravitational law both are inversely proportional to the square from the square of the distance. They are follow inverse square law. They follow inverse square law both, and both are centralized force. They are acting along the line joining the charge, or either force of attraction or repulsion. And the difference between them is Coulomb's law is attraction and repulsion both, but gravitational law is only attraction force, and Coulomb's law is very high force, that is very strong force, and gravitational law is very weak force. That is the difference. Coulomb's law is also acting by a charge that is called graviton. Due to the charge that is called graviton, and gravitational law also. Coulomb's law is applied due to the charge of photon, and gravitational law is applied by the charge particle graviton. That is Coulomb's law. And